So next we want to determine the maximum in-plane shear stress state of this given stress element. And what we're going to do is just go ahead and apply these equations here. And we're going to follow the same kind of process, determine the angle first, and then calculate the stresses. The one thing to remember in the maximum in-plane shear stress state is that all the normal stresses going around the stress element is that sigma average is the normal stress on each face, which is just simply sigma x plus sigma y divided by 2. Let's go ahead and do that. And the first thing I want to do is calculate the angle using this relationship right here. And that would tell me that tangent to theta s is equal to -1/2. If I bust the inverse tangent, I would get -26.56 degrees, which is the same as 26.56 degrees going clockwise. Theta s would just be 13.28 degrees going clockwise. There is a solution 180 degrees from -26.56 degrees. If I add 180 to it, I would have 153.44 degrees, and this would be the direction going counterclockwise. And here, this would also be divided by 2, would be 76.72 degrees going counterclockwise. But the reality is, in this problem, you only need one angle because the shear stresses on each side are the same. So tau max now, and I would venture to you that you've already solved this out before if you've calculated the principal stresses. And if we look back up above, you notice that this term right here looks exactly the same as what was done right here. They are identical, and that's because this is also the radius in Mohr's circle. This value is just 33.54 megapascals. So tau max is 33.54 megapascals. Sigma average is just sigma x plus sigma y divided by 2. And technically, you've also calculated this before, which was up here. This is sigma average. There you have it. You've got the shear stress, the normal stress, and the angles associated with it. And so all I've got to do now is draw my representative volume element. And I start that by drawing a line representing my 0 degrees, which in this case was horizontal. And the face I want to look at is 13.28 degrees going clockwise. So I'm going to go down 13.28 degrees. And now I'm going to complete the square or draw a square, first line being perpendicular to this 13.28 degree axis. And on this face, I have a positive 33.54 megapascals as my shear. And notice this is my new x prime. And keeping a right-hand coordinate system, my y prime will also follow in this kind of go along for the ride, if you will. And that means on this face here, my positive shear stress on the positive x direction would be in the positive y direction, y prime axis. So that means my shear stress goes like this. And the normal stress on all the sides is 5 megapascals, which means I have tension on each face. And this is my maximum in-plane shear stress state. You'll notice that the 76.72 going counterclockwise is with respect to the horizontal. So this angle right here, you'll notice, is 76.72 degrees. Yes! Alright, so hopefully these numbers and these diagrams match my Mohr circle video. Otherwise, I'm in trouble. But take it easy and let me know if you have any questions